Hello friends, this is DK Gautam and thank you for joining Interview Point. So guys, in this video, I'm going to discuss about solid principles. The solid principles are used by any other languages. So here, I will take example in the C# language. If you are a C++ developer or a Java developer, solid principle remains same for all the developers. Okay, so guys, I will take the example of C# language. So guys, the solid principles are 5 design principles in object-oriented programming that help developers to create scalable, maintainable, and robust software. These principles were introduced by Robert C. Martin and are widely applied in software design. These are developed by Robert C. Okay, those principles are applied in the software development. They have given 5 solid principles. So the first one is single responsibility principle, or we can say SRP. The second one is open closed principle. The third one is Liskov substitution principle. The fourth one is interface segregation principle, and the last one dependency inversion principle. So we are having 5 solid principles. Here I am going to discuss about single responsibility principle, guys. Okay, so before that I need to open my Visual Studio so that I can give you the example. Let me open my Visual Studio. Let me create a new class here. I will give the name of this class is invoice. So guys, first understand what this invoice class will do. Let me make it public. Okay, so I need to create some properties in it, public, and this one will be, and I will give the name as customer, and suppose I will take here list of string type. Okay, and then I need to take one more property called total, and that type will be double. Sorry, I have to give here items. Okay, now I need to create a method in it. Suppose public void calculate total. Let me provide the definition of this. Suppose total is equal to items dot count into 10. Guys, this is I'm taking just an example, and here let me define another method. Public method we use for save to database, and let me define this method as well. And here we can say invoice saved to DB. Let me create one more method, provide the definition for this as well. Okay, now here I will say email sent to customer, like this. Now guys, suppose if I am having a class and this class is having 3 functions. So what is the problem in this class? As we see, single responsibility principles, I have created this class just for understanding purpose. Actually this class is not following. So now here we are having single responsibility principles. Now understand here what it is saying. A class should have only one responsibility or region to change. In the simple meaning, it is saying a class should have only one responsibility. But in case of my class, these classes having 3 responsibility for the calculation purpose, and for the saving invoice into the database, and also sending the email notification. This class contains 3 things. So this class is not following single responsibility principle. So for that, what I have to do, I need to segregate this. So as you can see, a class should have only one responsibility or region to change. Now, so one class is having only one responsibility. So let's create one class inside it. Here class, and I will give the name as invoice repository. Invoice repository is my class name, and in this class, what I will do, I will implement only one method, that is this one. Okay, so I will copy the code, paste it here, and same way I need to create one more class, and the class name I will give as let me give the notification. Okay, so in this class what I have to do, I will write this code notification. Now understand here, because this method save to database I have moved into here, and this method send email notification I moved into the notification class. Now guys, these 2 methods are not required for me. So this class previously having 3 responsibility for calculation purpose, for sending the notification, and also saving the invoice to the database. So 3 responsibility was there within the one class. So what single responsibility principle says, a class should have only one responsibility or region to change. So that's why we have segregated this code into 3 different classes. So now this class is having only one responsibility. So what is the responsibility having this class as of now? Calculate the total. So this invoice repository class is having only one responsibility for saving the invoice into the database. And the third one is notification class is also having only one responsibility, that is for the sending the notification to the customer. Okay, now this way these are following the single responsibility principle. So as you can see, now our class is following single responsibility principle. So why this is very important for us? Here we need to understand it promotes the separation of concern, making the code easier to understand and maintainable. So now in future, this class is having only single responsibility, this class is also having single responsibility. The same way, this notification class is also having only single responsibility. Now as you can see, previously we are having in the invoice class, this is having three responsibility: calculate total, save to database, and send event notification. Now I have segregated this code into three different classes. First one is invoice. This class is having one responsibility. Second one is invoice repository. That class is also having only one responsibility. And notification. This class is also having one responsibility. Now, what is the benefits of following this single responsibility principle? That are better maintainability. Here, changes in one functionality, suppose database storage, do not affect other functionality, e.g. calculation or email. Suppose here I wanted to change anything into this function. So what happens? Only this class will impact, but our two classes will not impact. So my two classes are separate and it will not impact anything. So in that case, only this class will be changed, okay, and other class will not affect anymore. The second one is more testable code. We can write a unit test for each class separately. All the methods are separate, so for each class we can write separate unit test. So it also provide more testable code. And the third one is scalability. Scalability is nothing but easy to action functionality without modifying unrelated code. Suppose here in future I wanted to update anything in this class, so I am not dependent on to this class. So independently I can update this class, independently I can update this class, and independently I can update this class. So those are not dependent on each other. In that way it is providing scalability, so easy to action functionality without modifying the unrelated code. So guys, this is all about the single responsibility principle. Let's jump to the next principle, is called open closed principle. So what is open closed principle? Let's understand with the help of definition. So open for extension. You should be able to add new functionality without modifying existing code. Okay. And the next point is closed for modification, means existing code should not be changed when adding new features. So you can remember this point. Class should be open for extension but closed for modification. That line you need to remember. So now let's understand how we can implement this. So I have already created my code here. Let me open my Visual Studio. Here I have created one class, discount calculator. So as you can see, so in the normal customer it is giving 10% discount. If we are having a customer type is Black Friday, it is giving 30% discount. Suppose in future we are having multiple types of discount or customer. In that case we have to modify this class. So let's understand. So what is the problem in this? First problem is every time a new discount type is introduced. Suppose if I wanted to introduce Christmas discount, Diwali discount, Eid discount, in that case we must modify this class. And also there is one more problem. This violates the open closed principle because the existing code is not closed for modification. So it is violating the open closed principle. Okay. And the next point is more conditions. If, else or switch make the code harder to maintain and test. In future, new discount type is applied. In that case, I need to apply more condition, if, else or switch condition. So that make my code harder to maintain and test. So to overcome this problem, we will apply this open closed principle. So let's understand how we can make this code easy to maintainable. Okay. So first I need to create one interface called I discount. Okay, let me create a new item. I will say I discount. Okay, so I discount, and that what I will do, I need to create one abstract method, so double and apply discount. This will take only one parameter called price. So I have created this interface for applying the discount. Okay, so now what I have to do, I need to create two other classes. First I will take a normal class and second class will Black Friday class. So I already have this code. Let me copy. So I will go here. This my class. Okay, normal discount, and here we are applying 10% of discount. Apply discount method is implemented here because we are inheriting this I discount. Okay, this class is responsible for implementing this method. So I already implemented here. Okay, in the next I need to copy this code and also paste it here. So here we have created two different classes. For first one is normal discount, second is Black Friday discount. Suppose in future I am having Christmas discount, I can create a new class. In that case, I don't need to modify my previous class. So now here I need to introduce one more class, that will be discount calculator. So this is class, we are actually modifying this class. I can use in future. So let me comment this, and here so let me make this public. Now what I did in this class, I have created one interface, I discount, and this interface is implemented by this normal class, and this interface is also implemented by this Black Friday class. Black Friday discount we are applying 30% discount, and normal discount class we are applying 10% of discount. In case of we are having Diwali discount, we can create a new class and we can implement this. Okay, so here I have created this discount calculator class. So in that class, what I have to do, I'm just calling this apply discount method, and we are passing the price, so it will give us a new calculated price. Okay, so now let's try to test this. Suppose I have this program class, and let me write, okay, I will use this one. So here I am passing 100 rupees and 100 rupees. Let me write one more line here, console dot read line. Now try to run it. So let's understand this code. We are here, first we are calling normal discount class. We are creating the instance. So this instance will call this the discount of this into the normal class. Okay, normal class, what we have, normal class, how much discount it is giving, 10%, and Black Friday discount class is giving, here the discount is 30%. So in that case, so here I will get here we are passing price of the item is 100, here also we are passing price of the item is 100. So here our output will be 90, and here output will be 70 because here the discount is 30%. So let's try to run this, and you will see as expected output. So like this we can segregate our classes. So in future a new discount is introduced, what I will do, I will create a new class and I will inherit this I discount interface. That's what I need to do, and we can implement this. In that way we can follow the open closed principle. So what benefit we will get by applying this OCP principle? So first benefit is no need to modify existing code when adding a new discount type. Okay, so we don't need to change the previous class that we have introduced. What I will do, I need to just inherit this I discount interface. Okay, the next one is easier to action functionality. Just add a new class implementing I discount. That's what I need to do. By using this, our code is more maintainable and testable due to smaller focused classes. So that is the benefit of using OCP. So let's understand what is Liskov substitution principle in C#. So the definition is very simple. Subtype must be substitutable for their base types without affecting program correctness. It means the subclasses must be substitutable for their base classes. Or in simple term, we can say subclasses should not break the behavior expected from their base classes. So let's understand with the help of example here. I have created this class payment processor. Payment processor class is doing the payment functionality, process the payment. In future, I'm having two types of payment processor, for credit card and cash payment. So in case of credit card payment, we also need credit card number. So in that case, how we will get this credit card number? It will break the functionality because this function is required only amount, and here we also need a credit card number. So in that case, or we can say this class is breaking our functionality. But in case of this cash payment, in this case it is breaking fine. As per our definition of this Liskov substitution principle, subtype must be substitutable for their base types. So to achieve this, what we can do, let me comment this because I already created the code. So let me comment this as it is not required. I will rewrite this code to achieve the Liskov substitution principle. So what I will do, as I can see here, I have created this interface. Payment processor, I make it is a interface. In interface, I am having a abstract method called process payment. So in this process payment, I need to ask one parameter is called amount. The amount value I need to pass. So in case of credit card payment, what I am doing, I am implementing this interface. Process payment method is implemented within this class. Okay, but here through the constructor, I am assigning the value of this credit card. Now in this case, it will not throw any kind of exception. So our functionality will work as expected. But in case of cash payment, it will again implementing the payment processor. In the payment processor, it is asking amount field. So I will pass the amount and it will work as expected. So in that case, our functionality will not break. So let's understand here how I will call this method. So suppose I have created another class called program2. Here I am creating the instance of this payment processor through this cash payment. So in case of cash payment, I don't need any kind of credit card number. So in that case, I am just passing the value, or we can say amount. Okay, so this method is required only one parameter called amount. So I am passing the amount. But in case of credit card payment, here through the constructor, I am passing the credit card number. Here you can see our functionality will work as expected. So in such a way, we can implement the functionality so that the child class will not break the functionality of the base class. This is how we can implement this Liskov substitution principle. So here I already discussed about this code. So what is the problem in this code? It is violating the LSP principle. Liskov substitution principle, it is violating because here this method is breaking the functionality of the base type. So guys, in this code, we are having some problem. So what is the problem we are having? The credit card payment class adds a restriction. Card number is required. So which violates the LSP. Why it is violating the LSP principle? Because it forces client code to check for a credit card number before using the class. So we must have to provide the credit card number. That's why it is breaking the functionality. If we replace payment processor with credit card payment, it may throw an exception, breaking the expected behavior. So that is the problem in that code. So to overcome this problem, we have implemented this functionality like this. So first we have created one interface and then we have created two separate class. With the help of this interface, we are implementing this interface for both the classes, and through the constructor we are passing credit card number. But in case of cash payment, so we just need to pass amount as we can see here. So in such way we can achieve Liskov substitution principle. Okay. So what are the benefits of following Liskov substitution principle? Now any payment processor can be used interchangeably without breaking the problem. Suppose in future new payment type is introduced. So in that case, what I just need to do, I just need to create a class like that. Suppose bank payment will be introduced. So in that case, I will create a new class like this, and for that I just need bank account number. So I just ask through the constructor, and then I can provide the bank account number and then amount. Like this, we have implemented this way. The same way we can implement that feature again. So base type behavior will not change. Okay, so our functionality will remain as it is. Means our functionality will not break. Client code does not need to check for conditions before using the credit card payment. So as you can see in our example, as I discuss here in here, credit card payment. So client code does not need to check for conditions before using the credit card payment. So in case of future, if new payment type is introduced, we can easily implement like this. Okay. So more maintainable code and scalable code as new payment method can be added easily. So by following Liskov substitution principle, we can achieve these benefits. So let's understand what is interface segregation principle. As name suggested, interface segregation. So we have to segregate the interfaces. So let's understand. definition is very simple. A class should not be forced to implement interfaces it does not use. In such cases, we have to go for interface segregation principle. So let's understand with this example. So let me open my Visual Studio. Here I have created one interface called iWorker. So iWorker is having two methods. First one is work and second one is manage team. Suppose if I am having a class called developer, so developer is here implementing the functionality. Here developer need to work, but in that case developer doesn't manage team. Manager will manage team, but developer will not manage team. Developer just need to require this function. So this interface is forcing to implement this method as well. So what I have to do is, suppose in that case I am having another class called suppose here manager. For this it is fine, but for this class, for developer class, this method is not required. But if I will remove this, and now you can see we are getting error. So this interface is forcing this class to implement this method. So that is the problem in this approach. So to overcome this problem, we need to work with the interface segregation principle. Okay. So in this slide, as you can see, it is violating the interface segregation principle. So let's understand what is the problem in this code. Developer don't manage team, but they are forced to implement manage team method. As I already discussed, developer doesn't manage team, but they are forced to implement that manage team method. So that is one problem. Another problem is empty or throwing not implemented exception leads to code smell. So this code will not work as expected. So to overcome this problem, we have to work with the interface segregation principle. Let's move to the Visual Studio. Here, let's understand. Here I have created one interface called iWorker, and here I have created another interface called iManager. So here we have segregated our code into two different interfaces. First one is iWorker and another one is iManager. So developer class will implement this iWorker interface, and team manager will implement both the interface iWorker as well as iManager. So here we have to implement both the method. So like this, we have to segregate our interfaces. Okay, as you can see in this slide, with the help of this, we can segregate the interfaces, and this is following the interface segregation principle. So like that we can implement. So what will be the benefit of following interface segregation principles? Let's understand. No unnecessary method implementations. So we can avoid implementation of unnecessary methods. Code is cleaner and easier to maintain. Classes follows the single responsibility principles better. Easier to modify in the future without breaking other functionality. So in case of future, if there is any other interfaces required, we can directly create an interface. So this interfaces will not be required to modify. What we have to do, just we can implement those interfaces. So in future, our interface will remain same. So like this, we can implement interface segregation principle. So in this, we will discuss about dependency inversion principle. So the definition is very simple. High level modules should not depend on low level modules. Both should depend on abstractions. So let's understand through this code. I am having this code. So I have created here one class called email service. Here this is my concrete class, and it is having one method called send email. If you don't know what is concrete class is nothing but the class that is fully implemented. Okay, that is called concrete class, and also it does not require further implementation. Here email service is concrete class, and also we can create the instance of this class. Now here we are having another class called notification. Here in that I am creating one local variable of type email service. Here we can see, here in the constructor we are creating this object, and it is directly dependent on this concrete class. As you can see this, so we are using this constructor. Okay, so this directly dependent on this class, and in this class we are having one method called send, and by using this method we are calling this send email, this method. So what is the problem in this code? Let's understand. First problem in this code is tightly coupled. Notification is dependent on email service. As we can see here, this notification is directly dependent on this email service. Okay, so it is tightly coupled. And next one is hard to action. If we want to add SMS or WhatsApp notification, we need to modify notification class. As of now, we are having this email. In future, suppose I wanted to implement another notification type like SMS or WhatsApp. In that case, what do I need to do? I need to modify this notification class. So that is also one problem. So if we want to add SMS or WhatsApp notification, we need to modify the notifications class. It is also violating the open close principle. Every new notification type requires modifying notification. Suppose if I want to implement SMS type, then again we need to modify this class. Okay, so it is violating the open close principle. What is open close principle? Class should be open for extension but closed for modification. Like this, it is violating this principle. So let's understand how we can implement this so that it follows the dependency inversion principle. I need to comment this code as it is not required. First, what I will do, I will create the interface. Okay, so I have created one interface called iInterface service. So in this interface, I am having one method called send message. So whenever I need to implement a new type of notification, what I will do, I just implement this notification service. So in that case, this interface I need to implement. So here I am creating a email service. So in that case, I am implementing this iNotification service interface. Interface is containing one method, so I am implementing here. Okay, suppose future I wanted to implement another SMS service. So in that case, I again implement this interface, write our code like this. So in that case, we don't need to modify our notification class again and again. Okay, so what we are doing, suppose if I am creating a new notification type, so I am just implementing this interface. So that's what I am doing. But it is not violating the open close principle now because we are not modifying this existing class. Okay, so we can extend this class, but we cannot modify. Okay, here as you can see here in the interface, we are having only one method. So what I will do here, in the notification class, I have created one private variable called underscore notification service of type iNotification service. So by using this dependency injection, what I am doing here, injecting the abstraction. Abstraction is nothing but interface. Okay, through the constructor we are injecting the dependency. Okay, so in that case, I don't need to modify this notification class again and again. So like this, it is following the dependency inversion principle. So here I have created this interface service and here email service. I am just implementing this iInterface service. For SMS service, I am implementing again this. Here our code is separate, but we don't need to modify this class again and again. What we are doing in this class, we are just creating this private variable and injecting our dependency through the constructor. And through this SMS, we are calling the method. Whatever message we need to call, we can call. So like this, we can create our code so that we can follow the dependency inversion principle. So what is the benefit of using dependency inversion principle? So let's understand. Generally, when we will work on the dependency injection, we use this program.cs file. So if you remember, in the configure service section, we used to do this, injecting our dependencies. Okay, so like this we can do. So in the program.cs file, we can inject the dependency like this and we can call the method. So we can, for the email notification, we can call this method. For SMS notification, we are calling this method. So like this, we can inject the dependency. Okay, now this is not tightly coupled. Now, what is the benefit of calling? So the benefit is loosely coupled code. Notification depends on an interface, not the concrete class. By following the dependency principle, what is the benefit? Notification depends on the interface, not the concrete class. The another benefit is easier to extend. If we want to implement another notification type, suppose WhatsApp service, so we don't need to modify the notification class. Okay, so that is another benefit. So the third benefit is better testability. Can use mock implementation for the unit testing. So by using this dependency injection, our unit testing is easier. So like this, we can work with the dependency inversion principle. So guys, this is all about dependency inversion principle. Thank you guys for watching this video. We'll see you in the next video.